This video is regarding the line follower robot project we had this semester. This robot consisted of multiple functionalities, including line following, obstacle avoidance. It had a IoT device, which was the ESP32, which received the voltage and current values from the voltage current sensor that were attached to the Arduino Uno. And then the values were displayed on the cloud, which could be accessed from our mobile phones or our laptops. Another thing which this had was a SD card. What this SD card did was basically store the path the line follower took. It was the algorithm, it would store the algorithm which the line follower obeyed, and then without it operating its sensors, the line follower uh, could travel on the same path it took when the sensors were activated. Now, the first part of making any circuit, any robot, any product is making the schematic of the product. Now, this schematic is basically the circuit diagram of what you're trying to achieve. Now, this schematic consists of an Arduino Uno board, a motor driver, two IR sensors, one ultrasonic sensor for obstacle avoidance. IR sensors are for line following, and an SD card for storing the path. What this is missing is an OLED display and ESP32 and voltage and current sensors. Other than that, this was all our robot had. Now, how this robot works? Well, basically, we make a path first of all using black electrical tape. Then the two IR sensors they can detect the line because they can detect the black line, right? Because of the difference in the reflection of the IR light, infrared light. So when the right IR sensor detects the line, the right motor speeds up, turning it right, and the left motor slows down or comes to a stop. And when the left IR sensor turns on, the right motor starts driving, driving forward, and the left motor starts driving forward, and the right motor stops, which in turn keeps the line follower robot on track. When this ultrasonic sensor over here, when this detects a change or when this detects an object or obstacle in the way of the the line follower will come to a halt. Both the motors will stop, and then the line follower will rotate and turn back, and then this SD card will start functioning, and the line follower will go back go back following the path it came from. This was the schematic. Now moving on, keeping this schematic in mind, we made our PCB design. Give me a second. This is the PCB design. Now over here you can see these four what rectangles. Yeah, we'll call them rectangles. Over here, this is basically the bed for the Arduino Uno. The Arduino Uno will sit here. These two rectangles here, the ESP32 will sit here. Over here, the SD card, this is for the SD card. These 6 pins and these 2 pins. Over here, the motor driver will sit. Then we have I believe this was these these 3 pins here. These 2 pins, 4 pins here are 5 pins actually, are for the voltage sensor, and these 3 pins are for the current sensor. Over here we have the OLED display, and over this was for the ultrasonic sensor. Yeah, these were for the ultrasonic sensor. These three are for the IR sensors. Now, how this PCB design works is basically we can see that the ESP32 is connected via 2 pins only. Now these 2 pins are just the voltage and ground. We had to connect the ESP32, the Arduino Uno using top copper. So it's not over here. This is bottom copper, so we cannot see that circuit over here. But the receiver and transmitter pins were connected to the Arduino Uno receiver and transmitter pins using top copper. And this was all for the PCB design. Now we'll move on to the code. This is the code for the robot. We can see we use multiple libraries here. One is for the SD card, one is for the ultrasonic sensor, and then current sensor, voltage sensor, and the OLED display. Now later on, we realized we don't really need this new ping library for the ultrasonic sensor. We could have collaborated it without using this library, but regardless, we had to use this library. Looking at the code, we first have the SD card. We're enabling the SD card. Then we are enabling the motors. Then over here, this is the code for the SD card. This is where the SD card starts functioning and starts saving the path and everything. Going down, this is the values for this is how we activated the voltage sensor and current sensor. And this is for the ultrasonic sensor. Now this is the line following code. Over here, we had already declared the IR sensors. So this will now follow the algorithm of detecting the line and changing the motor rotation, motor speeds. And that is all for the code. You can find this code in the description and the PCB and schematic as well. I will attach my GitHub link in the description of this video. Now I'll show you a few videos of the robot in action. Um, as you can see, it's following the line. There was another video as well. Let me share it. Okay, now I'll share the screen again. Another video of the functionality of the robot, as you can see, following the line perfectly. Now I will show you guys I'll show you guys the PCB and the hardware of the robot as well. I hope you guys can see. This is the PCB for the robot. As you can see, we have the SD card over here. We have the ESP32 over here, current sensor, voltage sensor. I'll take this off. These pins over here, the board, the motor driver will sit over here, the ultrasonic sensor here, OLED display over here, and yeah, the sensors and the IR sensor will come here. And these pins, this is for the Arduino Uno. This is an Arduino Uno. This will sit on top over here. And this is the chassis or chassis of the robot. This is a motor driver which will drive these motors. You can see the motors. And this robot uses 12 volts. So these are 3.6 volts each, which makes around 11 volts. and the two IR sensors are at the front. This is a three-wheel drive robot. These two wheels, these are the two motors attached to the wheels, which will control the direction of the motor, direction of the robot. And this is just a metal caster wheel. I believe that is all. Thank you for watching. Allah Hafiz.